Alright, this is the section of notes for Algebra 2. This is section 2.2, pages 82 through 85 in your textbook, dealing with slope and rate of change. Now, the slope of a line, m, is the ratio of vertical change to horizontal change. We've seen this before in Algebra 1 and in geometry, and we're going to be seeing it again throughout the course of the year. We'll typically show slope in one of two ways, either algebraically or graphically. Now, algebraically, we show the slope of a line as the letter m. You can see here the letter m, and we see it in equations such as y equals mx plus 2. We can find the slope of any line if we're given 2 points by using the slope formula typically found on the tax formula chart. It's y2 minus y1 over x2 minus x1. This is set up as a fraction, and if we have to find the slope of a line, all we need to do is assign 1 point to the first point, 1 point to the second point, and do a little bit of arithmetic. You might see this formula written as what's called delta y over delta x. The delta basically just means the change in y over the change in x. Graphically, you might see the slope of a line referred to as rise over run. You see the same kind of information. We see 1 point x1, y1, 1 point x2, y2, and we find the difference between y2 and y1 is how much it rises, and the difference between x2 and x1 is how much it runs. So, we might be asked to find the slope of a line passing through 2 points. We're going to do a quick example here. We have 2 points, 1, 3, and 6, 7. We want to find the slope that passes through them. In order to do that, we use this slope formula. It tells us that m equals y2 minus y1 over x2 minus x1. Now the first step here would be to decide which point we want to have as x1, y1, and which point we want to have as x2, y2. It makes no difference which points we choose for what, as long as we're consistent about it. So, since 1, 3 comes first in our problem, I'm going to say that one is x1, y1. And since the point 6, 7 comes second, I'm going to say that one is x2, y2. It's always a good idea to define the point and label each of the x's and y's. That way, when we're actually plugging values into our formula, it's a little more straightforward and we don't have to guess as much. Now, my formula says y2 minus y1, and I have 7 as y2. I have 3 as y1. So on top of my fraction, I have 7 minus 3. On the bottom of the fraction, x2 minus x1, I have 6 as x2 and 1 as x1. So on the bottom of the fraction, I have 6 minus 1. We do a little simple arithmetic here. I've got 7 minus 3 on top is 4. 6 minus 1 on bottom is 5. I cannot simplify this fraction, so my answer will be that the slope of this line is 4 over 5. Let's try it with different points. These points are negative 3, 2, and 1, 4. Again, the first thing I want to do is define, okay, this point is x1, y1, this point is x2, y2. So I will call negative 3, 2, x1 and y1. I will call 1, 4, x2 and y2. My formula tells me that m equals y2 minus y1 over x2 minus x1. So when I start plugging things in, y2 is 4, y1 is 2, so 4 minus 2 on top. On the bottom, x2 is 1, and x1 is negative 3. So I want to write this as 1 minus negative 3. What I don't want to do is accidentally write 1 minus 3 because that would give me the wrong answer, and we don't want that. So we do again a little simple arithmetic. On the top 4 minus 2 is 2. On the bottom, 1 minus negative 3 is the same thing as 1 plus 3. 1 plus 3 is 4. Now this fraction, 2 over 4, I can simplify. 2 over 4 simplifies into 1 over 2, or 1/2. So the slope of this line is 1/2. Now there are several different types of slopes. A slope can either rise, fall, be horizontal, or vertical. And depending on what type of slope it is, we know some information about the number m. For instance, our first example here, this slope going from left to right rises. So if the slope is rising, the slope rises, that means that m is positive. Whatever number it happens to be, we know it's going to be a positive number. In our next example, we see that the slope going from left to right is falling. If the slope falls, that tells us that m is going to be negative. Doesn't matter what the number is, we don't know that, but we do know that that number is going to be negative. Horizontal and vertical are a little different. A horizontal line is one that just goes left to right, so this line is horizontal. And what it tells me is that m equals 0. Anytime I have a slope of 0, I have a horizontal line. The odd man out here is a vertical line. Our last example shows a vertical line. Remember, a vertical line is one that goes straight up and down. This is, like I said, it's kind of the odd man out, because when a line is vertical, that means that the slope is undefined. And if the slope is undefined, that means we do not have an m at all. Alright, so let's do a little example here. We've got a couple of different situations, a couple of different sets of points, and we want to tell without graphing the line whether the line is positive, negative, 0, or undefined. Whether it rises, falls, is horizontal, or vertical. In order to do this, we use the slope formula. So we say m equals x2 minus x, or y2 minus y1 over x2 minus x1. So let's try with this first example. I have the 2 points, negative 6, negative 2, and 1, 3. Our formula says that m equals y2 minus y1 over x2 minus x1. I want to define what point is what, so I will say that negative 6, negative 2 are my x1 and y1. 1 and 3 will be my x2 and y2. So, I have y2, 3, minus y1, negative 2, so 3 minus negative 2, over x2, 1, minus x1, which is negative 6. So 1 minus negative 6. So here again I have 3 minus negative 2, which is really just 3 plus 2, and 1 minus negative 6, which is really 1 plus 6. So I've got 3 plus 2 is 5, 1 plus 6 is 7. My slope then is 5 over 7. 5 over 7 is a positive number. That means that since it's positive, the slope rises. Let's try the second example. I have 2, negative 1, and 2, 2. So Our formula, again, y2 minus y1 over x2 minus x1. I'll say that 2, -1 are my x1 and y1, and 2 and 2 are my x2 and y2. So my formula says that y2 is 2 minus y1 is -1, so 2 minus -1. On the bottom, I've got x2 minus x1. x2 is 2, and x1 is also 2. So I have 2 minus 2. A little arithmetic here. 2 minus -1 is 2 plus 1 is 3. 2 minus 2 is 0. But we've run into a problem because we are not allowed to have 0 on the bottom of a fraction. If we have 0 on the bottom of a fraction, that means we're dividing by 0, and of course we cannot divide by 0, that is against the rules. So this is undefined. Anytime we divide by 0, we end up with something that's undefined. And since it is undefined, it is vertical. The line in the graph here would be vertical.